Hello students, today our first point is reverberation. So what is reverberation? We all know auditorium or hall, in which we can consider 2 points. This is auditorium or a hall. Here it is a speaker and here a receiver or a listener. Now what happens when the speaker starts to give his speech or the sound source generates sound gets directly by the receiver. The receiver receives the sound directly. So also this, as it is a sound source, it can generate sound in all directions like this. So this reflected sound again goes to receiver by the reflectance of the wall of auditorium, we can say. Now, due to these reflected sounds, these reflected waves, the intensity of sound increases over time. Okay, because this is a direct sound and this is also a reflected sound. So gradually, as we go from 0 to say time instant t, the intensity of sound increases. But what happens when the sound source stops is generating sound? Now what happens after cut off this sound source, the receiver can still hear a sound. Okay, so that extra amount of sound, that extra prolongation of the sound is called reverberation. Now what is reverberation time? That reverberation amount or that reverberation time must be precisely good, so we can get a good quality of the speech. Now what happens if it is less, we will get a bad quality of the speech, and if it is higher, we will get a noise. Now consider this graph where we have plotted intensity of sound and time. So what happens when sound source starts generating sound? Initially it increases over time rapidly and then it saturates here. Okay, so we can give points here. A, B, it is increasing very rapidly. Then due to reflections, it is coming to, after reflections, it is coming to saturation. So here is C, B, here it is saturation. Okay, the maximum sound. After that, what happens when the source stops its sound? Source stops generating sound. It will decrease gradually or exponentially like this. So, and it will decrease over time. So, what is this limit? It is audible limit of human ear. So, difference between this point and this point here is called reverberation time. So, for this time of interval, the sound has prolonged for this time. So, this is reverberation time. Scientist Sabine has found the relation T is what? Reverberation time between volume of hall and capital is area of the effective absorbing area of the materials in that hall. So what we have got? Sabine find out that the reverberation time is directly proportional to the area of that volume of that hall and inversely proportional to the total effective absorbing area of the materials, or the, we can say, curtains, cushions, peoples in that auditorium. All that material, we can say, its effective area of absorption. So this area also there, so it is inversely proportional. Now, so this is simple relation formed by Sabine. Now, so our next point is absorption coefficient. What is absorption coefficient of any surface? So absorption coefficient of any surface is the total amount of sound energy absorbed by that surface to the total sound energy incident on that surface. So it is a ratio. Okay. So absorption coefficient of any surface is a ratio between total sound energy absorbed by that surface to the total sound energy incident on that surface. Now, Sabine introduced Sabi introduced you can say standard to measure the absorption of sound. He created, or he assumed a 1 feet square window, that is open window, as an ideal absorber or a standard absorber. That means if you consider an open window of 1 square foot, then what happens? It will absorb all sound energy passing through it. Okay, it will absorb all that energy. That means it is an ideal absorber. That means it is absorbing 100%. Okay, so it is an ideal absorber. Now, if you want to find a absorption coefficient of any surface, we can find it by consider a surface, arbitrary surface, whose total area is S, capital S, and then we can give the relation capital A is equal to small a into S. So what is this S? S is the total area. Okay, sorry, total surface area. Then A is a coefficient of absorption. And what is A? A is effective absorption. Sorry, A is effective absorbing surface. Effective absorbing surface area, we can say. So this is effective. That means we have whatever the sound energy falling on that total surface, it is not absorbing the complete. Okay, so it is absorbing small quantity. It will reflect some amount. So this is always less than the capital S. So we can relate this as a consider this capital S as a like this surface area. Now what happens when sound energy falls on it and the sound energy gets absorbed? We get effective area like a small area. Okay, like this. So that means this area out of the total area, this area out of the total area can absorb the complete sound. Okay, complete sound energy falling on it. So this is equal to, we can say, one open window. Okay, that standard we have set for absorption of sound. So it is equivalent to open window. So Sabin found that, or he has set the minimum or standard for absorption of sound. Now what happens when in auditorium there are so many curtains. Okay, curtains, we can say tables. There is some audience, like so many audiences there. So person are there. So persons, their clothes, we can say. So these are the factors which affect the absorption coefficient. Okay, the curtains are good absorbers. Okay, so by adjusting these, and also the architecture of the auditorium or hall also plays an important role in the absorption coefficient, or we can say reverberation time. So these factors contribute to the absorption coefficient. Now by changing the individuals in the auditorium, we can change the absorption coefficient. Now an average human average person creates absorption of 4.7 feet square feet of open window. So this is for one person. So by controlling the amount of persons in the auditorium, we can control the absorption coefficient for a good quality speech. So that was all about reverberation time and absorption coefficient. Thank you.